So we're group 4. Yeah, so we did the same thing as the previous.
Alright, pay attention, please.
Yeah, so this week started, and we started out by going through the basics of human anatomy, which would help us for the arm. And then we went through, obviously, Tuesday we went through the book on robotics, so we learned how to really interact with the robot to get it, manipulate it to get what you want out of the robot. So that was good fun. So we did all these things. We started on, we started on Tuesday by dividing up our labor. So Bright and I took the iRobot, Brooke and Ellen took the Vex, Kate, and Cameron and Peter took the Lego thing. It was, so they tied in, all the projects tied in together with fields of engineering differently. So the iRobot kind of only dealt with computer science and how to get the robot to respond to your commands to get it to do what you want most efficiently. Because if it went through, if it took forever to search for it and came back, and it took it forever to come back, it would kind of be useless because the guy would have already died and it would just wouldn't work as a search robot. So we had to find a way for it to get to and from the person it was trying to find most quickly. And it ended up being pretty simple, actually. And then for the bioengineering part, which is the arm, we had to tie in what we learned from the chicken feet and kind of model that mechanically rather than using a real organic tissue. So Cameron will talk about the Lego robot.
All right, so for Lego robot, we had a couple of different designs. We started out completely different, but our first idea was to have a three-wheeled robot with a caster in the back that swiveled so it could turn easily. And we had a side sensor so that it would sense when it got to the edge of the object and be able to turn accordingly. However, when we were testing it, we found out that it was unreliable, and we scrapped that idea and went with the line following because that sounded a lot more reliable and we knew it worked. So what we did was we took off the caster, turned it around, and just made it glide with 2 wheels and put on the color sensor. And then we used another sensor, a touch sensor, to know when it got to the obstacles. What did I say?
Like Cameron said, we first tried to use touch sensors only for our first design. And he said, and like Cameron said, it wasn't very reliable and it was also very hard to program. So then we decided on using a light sensor to follow the black path, and it was much easier to program. But so we lost about a day doing our original design, so we only had 2.5 days to do all 3 of our projects.
Okay, another couple of obstacles we had were when we made this design, going down the stairs, it wouldn't work going this way because it only has 2 wheels in the back and it's getting stuck on the stairs. So what we did was we made it go down backwards and then turn around from the bottom so that it could actually make it. And also we found that it was hard to, we had a shortage of computers, and working over gerontology and sending feedback here didn't quite work because you always had to constantly send your feedback. So those were just some of the obstacles we had.
And the shortage of computers in SSL didn't work out very well either. So the improvements to our project, I think we should have done more testing here because then we were like experimenting with arbitrary things like bugs and buckets or whatever, and those weren't exactly these. So then we had to like change things in our design.
And also we should have thought through our design, our initial design beforehand so that we didn't waste time.
Should I go on that?
That's
I wanted to go to, okay, that's good.
Alright, so me and Ellen did the Vex arm, and
designing the actual robot over there, and then we programmed like today, but we first started with our design of it. And once we got to the programming parts, some of the gears were stripped, so it didn't have enough power to actually like lift some of the parts in the robot. And then also we once we actually found like a problem in it, it took us a while to fix it because lack of computers. Yeah, other than that, I like doing that. And also, like, as in Brooke and I, we spent probably the whole morning to planning the double arm, so we do not have enough time to kind of to test the thing. So we just test the start from this afternoon. And also, like, some of our models do not work very well. So we tried some models again, and it's much better.
We need to go back to the iRobot slide. It's just like not the slide goes. All right, so we're gonna talk about the iRobot. It's kind of it's not slide. It's this slide right here. So if you read that, like,
Just stop at the
whatever. All right, so Bright and I did the iRobot, and one of the things that was really helpful was to have a computer lab in gerontology, kind of to ourselves this morning and yesterday. And it was actually really helpful to have, I can't remember his name, so it's a bit embarrassing, but
Naranjan.
Naranjan to help us out. He was really helpful, but it was difficult at first. Yeah, you can go ahead and talk.
So like we spent about a day doing stuff like guess and check. We didn't really go learn like all the language of the program C, so we didn't know what to do. So it was like kind of random. We did one thing and we go check it randomly. But at the end, like Ninja came in and his name is Ninja. Also, so like we had like many syntax errors and we didn't know how to fix it. So Ninja came in and we got it there.
Yeah, we did that. And then, we did this. Good. Next. So this is like the whole. So one thing we could improve was to have better communication within our group, because we were kind of, no one really know what we were doing in terms of like the Prezi and the web journal, because we were so focused on our individual projects that had tunnel vision, forgot about the other stuff. So we probably could have improved with that. I guess it didn't really matter with the iRobot because there was no building of it, but with the other two, it would have been better to have a clear idea of what each thing was actually going to do, and then especially with the arm, how each, because it's great to have a plan, but if you don't know what each component can take and what your design is, what kind of stress it's putting on each component, it's difficult to know if it will actually work. And the final one, which is kind of most important, is better time management, because even today with the iRobot, it ended up being like only 4 lines of code that we wrote, and it still took us like 12 hours all told to get there to that point. So better time management is crucial.
Can I say one thing?
Sure.
Initially we thought this was gonna the obstacle course was gonna be a maze, and so we built a role following robot. That kind of, yeah. So yeah, go on.
Starting to get better use of time, same slowly. The end. All right. What are you doing for your first?
You get them. You get them.
Or giant Lego.
We started. We gotta do over. One do over.
One do basic purpose.
The rules of engineering.
Well,
Is that backwards?
I did one after. Everybody gets one.
Nice.
Got wheel spin.
keep going.
Oh.
Come on.
Very
left. Turn left.
Next.
Left.
Okay, well,
There's nothing.
No, we did.
You're spinning on the tape.
Yeah, you lift that arm up. There's like an arm that's down.
Where, this one?
what the heck? It was working earlier.
You're almost there.
Yeah, so think on the side.
Whoa.
Nice.
It doesn't work this time.
Oh,
It is.
Yeah, it died.
no, it's good. It's good. It won. We did it.
The wheel.
Yes. We did it.
Then your arm is.
No.
Almost.
Almost.
Arm or iRobot?
Why doesn't this turn on with you, right?
Can I get through? You can do it. Just remember when to switch it off.
To the walls.
How is this funny? This is. Alright, just place it in there when it comes.
Don't be patronizing.
I'm not patronizing.
You're patron-
How come we never hit on Calvin?
Are we going?
Yep. You're supportive.
Try again.
I think the key is
Should we
ours
go again?
looks like an arm.
We're going
The others
again.
didn't really look like an arm. I think
You didn't
that's
start
how
it from the
much
right
work.
position,
I
right?
know.
Did you get your arm?
Whoa, you're saying ours didn't look like an arm? What's that supposed to mean?
Okay. Alright.
Oh my gosh.
Justin.
Why did it fall? What happened?
Why is it dropping?
gives a.
It's that
Alright.
up there. Up
Well,
the shoulder.
It worked before.
Yeah.
Wait, take a video of it.
What?
Take a video of it.
I can verify that it worked before.
Come on, Jacob, move your leg. Yeah, ours did before too.
Am I blocking anyone?
Alrighty.
No, other way. Oh.
Alright, it'll angle and then it'll go right to it. Look at it. Look at it. Yes. Go on.
Yeah, you got it.
You found it, right?
Yeah.
Yeah.
Go
Shall we
home.
go back to
I got it.
Right here. Go right here. Right here.
Oh.
Don't do. Right here.
It's not a dog.
Yeah, the person's got it.
Come
He's
on.
touching it.
I love the cinder block.
Following this down just to walk around.
Come on, come on.
Oh.
Yeah.
Yeah. He's right on, I think. Yeah.
Success.
That doesn't count.
He's never
It's
tired.
fixing its placement.
Realign.
Turning how to park.
Yeah.
Woo!